Today we're going to be talking about the sum and difference identities. The first set of formulas are given for sine. Now, when I was taking trigonometry in high school, the way that my trig teacher had us memorize this is she would kind of yell out a song, and ever since then it's always stuck with me. So for sine, you have to remember that both sine and cosine are very narcissistic, and so the first thing that's going to pop up is the matching trigonometric function. So for sine, the first trig function that pops up is sine because they're both narcissistic. And so for both of these formulas, we have sine, cosine, cosine, sine. Same with this one, it's sine, cosine, cosine, sine. And then the other thing to remember is that sine starts with S, and so basically we have same starting with S as well, same sine, which both start with S. So that means that if you have the sum of two angles, then you'll have sine, cosine plus cosine, sine. And then similarly, if you have minus, you'll have sine, cosine minus cosine, sine. And the formulas for cosine are cosine, cosine, sine, sine, and then the signs are going to be opposite since it's not S in this scenario. I know that's kind of silly, but it helps me remember the formulas. And unfortunately, I don't have a great way of memorizing the formulas for tangent. So those you'll just have to memorize on your own without a mnemonic device. Let's go ahead and jump into some examples. Example 1 wants us to find the exact value of the following things. So part A says cosine of 15 degrees. Now, 15 degrees is not one of the common angles that you find on the unit circle. However, you can rewrite this thing as cosine of 60 degrees minus 45 degrees. These are both angles that are commonly placed on the unit circle, and they are angles that we know the cosine and sine values of. So now we can plug in the difference formula. And again, if you remember that mnemonic device singing that song, first of all, cosine and sine are narcissistic, so it's always going to start off with the same matching thing. And for cosine, it's cosine, cosine, sine, sine. So that means that we'll have cosine of 60 degrees times cosine of 45 degrees. And then it's going to be the opposite sign, so plus sine of 60 degrees times sine of 45 degrees. So let's go ahead and fill in those values. If you are on the unit circle and you have 60 degrees, the terminal point here is 1/2 comma root 3 over 2. So cosine of 60 degrees would be 1/2. Cosine of 45 degrees is going to be root 2 over 2. Plus sine of 60 degrees is root 3 over 2. And sine of 45 degrees is root 2 over 2. And that ends up equaling, if we do multiplication, we'll get root 2 over 4 plus root 6 over 4, and then we can combine that into one fraction. So we have square root of 2 plus square root of 6 all over 4, and we can't really simplify that any further. And don't forget, it says that we want the exact value, and so we don't want a decimal approximation, so we'll leave our answer like that. All right, so part B says tangent of 7 pi over 12, and this can be written as tangent of pi over 3 plus pi over 4, because pi over 3 is the same thing as 4 pi over 12, and pi over 4 is the same thing as 3 pi over 12, and 3 pi plus 4 pi gives us 7 pi in the numerator. So now we can use this to figure out the tangent of 7 pi over 12 using the sum formula for tangent. All right, so this is going to equal tangent of pi over 3 plus tangent of pi over 4 over 1 minus tangent of pi over 3 times tangent of pi over 4. And this was just taken from the formula that we have up above. I didn't do any calculation or anything there. So now tangent of pi over 3 is equal to the square root of 3, and tangent of pi over 4 is equal to 1. So I'll fill in those values. So that's going to give us the square root of 3 plus 1 over 1 minus the square root of 3. And I want to get the square root out of the denominator and rationalize. So the way that I'm going to do that is I'm going to multiply both the numerator and the denominator by 1 plus the square root of 3. And if we do that, we are going to get, let's see, square root of 3 plus 3 plus 1 plus the square root of 3 over 1 minus 3. So if we simplify the numerator, that's going to give us 4 plus 2 root 3 over negative 2. And then, let's see, how do we want to do this? We can factor out a 2 from the numerator, and that will give us 2 plus root 3 over negative 2. And then these will divide out, and we'll be left with a negative 1 in the denominator. So our final answer will be negative 2 minus the square root of 3.